In the previous video, we saw how we can sniff any login, any username and password that the user enters in HTTP pages. Now, unfortunately, most websites use HTTPS. So websites like Facebook, Yahoo, Gmail, all them, they use HTTPS. That means that these websites are validated using an SSL certificate. And when we're doing a man-in-the-middle attack, they will be able, the browser will be able to identify that the SSL certificate is invalid, and it will display a warning to the user. We saw that in the previous video when we were going on Google and on Yahoo. We saw that Firefox was displaying a warning to the user. To bypass this, we're going to use a tool called SSL Strip. SSL Strip will downgrade any HTTPS connection to HTTP. So the packets are still going through our device. SSL Strip is going to, whenever it sees a HTTPS connection, it will downgrade the URL to a HTTP, to the HTTP version of that page that the user is trying to access. So the first thing we're going to do, let me just first show you one thing to modify in the configuration file. So in the previous video, we removed the comments for IP tables, and there's one thing you'd also need to do. So genie etc itercap iter.conf, just the configuration file for itercap, same one that we modified last time, and just modify the UID and GID to 0, the privileges, and save that and quit. So the first thing we're going to do to downgrade HTTPS connections to HTTP, we're going to add a IP tables rule. This rule will redirect any packet that's coming on port 80 to port 10,000. IP tables is a firewall for Linux, and we're using it to redirect any packet that comes on port 80 to port 10,000. We do this so that, because SSL Strip runs on port 10,000, so that we're going to, any packet that comes to us, it's going to be analyzed by SSL Strip, and if it's a HTTPS, if it's a request for HTTPS page, we're going to serve the HTTP page instead of that. So I'm going to hit enter for this, and that's done. Then we're going to run SSL Strip, which is very simple, just SSL Strip P. You can just run SSL Strip to sniff all the requests, but for P, that's only for post requests. So that's the requests that contain users and passwords. And it's running now. Now we need to ARP poison the target. So we're going to need to tell the access point that I am the client, and tell the client that I am the access point. So it's text mode quiet m ARP remote I land 0, and then specify the targets. Gonna hit enter and make sure the targets are imported correctly, and that's right. Then I'm gonna enable IP forward, and everything is ready now. We're gonna go to the target device now and try to log into Facebook and see if we get a warning or not. So I'm gonna go to facebook.com. And notice that I didn't go to the HTTPS version of Facebook. I'm at the HTTP version. So the user didn't say, so we're not actually decrypting HTTPS or any of that. We're only changing, instead of letting the user go by default to the HTTPS version, we're gonna let him go to the HTTP version. So if I sign in, I'm gonna say Zaid at isecurity.org. I'm gonna put a password. I'm gonna say test pass. I'll log in. Let's go here. And as you can see, we were able to sniff the user login. So the password is test pass. He's trying to access facebook.com, and the username is zaid@isecurity.org. Let's try to go to Gmail, and we're gonna log in with, again, zaid@isecurity.org, and we're gonna say Gmail pass. And we go here, and we can see that the user zaid@isecurity.org and trying to log into Gmail pass. The password, sorry, is Gmail pass, and it's trying to log to accounts.google.com. As I said, here again you can see that the connection is HTTP and it's not HTTPS. The only way you can notice that is if you see the lock icon here, that means it's HTTPS. So we can't see the lock icon, which means we're in a HTTP page, and we can still sniff it. So the user is not seeing any warnings about that, and we're successfully sniffing his users and passwords. Now this attack will not work if you try to access Gmail from Chrome, because Gmail uses a new feature which is called HSTS, and that basically forces the browser to serve the HTTPS version. So even when SSL Strip tries to downgrade to the HTTP, the server there, like the Gmail server, will not allow that to happen. It will only serve the HTTPS version of the page. That only works with Chrome, however, so we can see from Firefox, this is the latest version of Firefox, and it still doesn't work with it. So it's only when you use Gmail with Chrome. So we're going to go to Chrome, and I'm going to go to Gmail. And as you can see, we're getting a warning here. So the HSTS feature renders this attack unusable, but it only works with Chrome. It doesn't work with any other browser.